Now I want to talk more about the management features about Cloudian, right? So just providing we talked about how to store data, but by itself, that doesn't give us an object storage system that an enterprise can use. So in order to make it enterprise ready, we have to provide a lot of capabilities on top of the object storage. And this is all built upon our APIs. So via our admin APIs, our extensions to the S3 APIs, we provide all of these types of capabilities. So we have role-based access. We talked about the 3 different types of users, and these are system users, group-level users that manage each tenant, and then the users that belong to each of those groups. At the access level, we have the different buckets or objects that you could provide fine-grained access control to. So you might have like a read-only object, or you might have a bucket that's publicly accessible. Quality of service is something that's necessary in a multi-tenant system. We don't want one tenant to take up all the resources of the system. So you could put controls like, I want the accounting department only to have this many requests per second, versus the engineering department should have this many requests per second.
Can you roll back to RBAC for a second? LDAP/Active Directory?
No support for that yet. That's on our roadmap, and we've been trying to understand how
That's,
right?
yeah, 5.2 release. We're planning 5.2 June, July. Happy to share that.
Because for the enterprise folks in the room,
Absolutely need it.
that becomes essential.
Absolutely need it, yeah.
Right.
Could you characterize the performance of the system, objects per second ingested, and stuff like that per node? I mean, do you have any ideas what those things are?
Vikram, you want to talk about that?
Sure. So I think it all, obviously, we all know it depends on the workload, like how you want to push the system. So we have done various different types of tests. So for example, we did, as I mentioned, the scale test, 200 nodes, billion objects. But from a performance perspective, I think the objects per second is again something that we are starting to test based on workloads. So for example, if is it large objects, small objects. So we see that are sub K or sub meg objects. Then you have 10 gig objects, 1 meg objects. So
small object ingestion performance, large object data bandwidth performance kind of
correct.
thing.
So right now we are measuring bandwidth. And I think the performance question is always a little bit tricky in terms of how you measure it. So we are actually boiling it down to how much we can push each drive, because everybody comes up with a number and you don't realize, okay, how many drives in the system.
And the disk drives are 72 RPM.
7200 RPM, your standard drives. And we are able to see, again, depending on if it is large objects, we can go up to 30, 40 megs per second. Or if it is smaller objects, then again, if it's coming from Cassandra, it's a lot larger, right? So there is a performance paper that we have. We can definitely share that. But again, a performance is obviously a very loaded question, and if you want specifics of it, we can definitely go through that. But I think for larger objects, the system gets better and better because you write sequentially, and we can drive using vNodes a lot more bandwidth out of them.
So one of the important things on these capacity storage systems is not just what you can drive in terms of one node in terms of the throughput. It's often capacity is actually the big thing that drives it. So we completely horizontally scale our performance. So in the performance paper, and we can share some of it, you'll see actually horizontal scaling as you add nodes, that it actually does purely continue to grow in terms of bandwidth, right? That shows the peer-to-peer capability, and that's a really important thing. So as you want to kind of grow bandwidth, you can just add in a new node. You'll know you'll get the increased performance.
And the object ingestion rate also linearly scales with nodes, or?
The object ingestion rate, yeah, linear scales with nodes. Again, assuming that you're going to be balancing all of your front-end requests across all nodes, right? And so that's really how you set up your load balancer, or whether you want to do round-robin load balancing. But there's something that's going to be redistributing the initial HTTP request into every node.
And when we get to the analytics piece, we'll know how that plays. If and when we get to the analytics piece.
Yeah, even when we get to the analytics piece, and we'll show you actually what we do in terms of locality for analytics. So I think that's a key thing.
Okay, so I'm quite over. So, but
Gary, I think we'll skip the management demo. We'll just go through some of the key capabilities here.
Okay. So on the monitoring, we have SNMP and JMX. So via alerts, we have the reporting and chargeback capabilities. And on the security, we have the encryption, AES 256, per object encryption. So this is based on the S3 API. You're able to have the customer own the encryption keys and then pass it over to the system. So that's a new compliance requirement. And then as encrypted in the cloud is referring to the tiering. So as we tier off to Amazon or another S3 system, that encryption is still maintained, and then we decrypt only on our server when we go back to the client for the full security of that.
So I'm sorry, I just missed that. You can actually encrypt on an object-by-object basis. So one bucket could have plain text as well as encrypted objects?
Yes, yes. That's a property of actually the S3 API, one of the new ones.
Okay.
Okay, and this just gives you a flavor of what we mean by programmable APIs. So a system would actually make these types of HTTP requests. This is an example of grabbing usage data. So many customers don't use our billing, but they want our usage data to feed into their own billing system. So this is what they use. This just gives you some screenshots of our management console, monitoring on a per disk basis, on a per node basis, on a system basis. We're able to define notification rules for monitoring. So it comes with out of the box, it comes with a set of pre-configured rules that we think are important for monitoring service health. But then you could also add more rules and define your own thresholds, like, you know, when my CPU is above 9%, then send me an alert. And so we want to skip this one. And then on the multi-tenancy, so let's talk about how this actually manifests itself to the end user. So first, when you log in to the management console, you'll see only those capabilities that you have access to. So the system administrator will have full access, all screens, all tabs. A group administrator will have a more limited, so they're only allowed to manage their users and the capabilities to their system, right? So like Paul was talking about earlier, we might not want to allow a group admin to say, okay, you could store in erasure coding and you could store in replicas. You might reserve that only for the system administrator level. At the user level, you could also log in. Mostly at the user level, you'll be looking at reports and looking at a view of your data via what we call the Data Explorer. So that's what you could use to add objects, delete objects, and so on.
In your multi-tenant approach, you can grant a certain capacity limit to, hey, they paid for this much capacity, so I give them this much.
Yeah, exactly.
Yeah, and also capacity is sort of defined by the amount of storage and also by number of requests coming in, number of requests going out, also the number of bytes coming in, number of bytes going out.
So you can get granularity on requests like that as well.
Yeah, so
with the QoS, beautiful.
These 5 properties, so number of bytes you have stored, number of objects you have stored, requests per minute, inbound bytes, so this is data transfer rate, in and out. And then these are in near real time, these final 3. So, well, actually all of them are in near real time. So as you exceed your limit, you'll have a cool-off period where requests from you will be rejected until the counters reset, and then you're able to resume the traffic.
And what's important is you can manage these by users or groups, and so you can actually set, generally people do it by groups, right? So you can set the controls at a group level in terms of what, and it doesn't then matter how many of those pools of storage, right? What we call buckets, just like Amazon, but those buckets of storage, your QoS controls are across all of your data storage.
So when someone hits the cooling off period, does it just simply not deliver data? Or like in the case of, I mean, you're saying buckets, Photo Bucket would have you exceed your throughput for your account. Therefore, it sends you to you've exceeded your throughput for your account page. Yeah,
you'll
still generate.
You'll get a particular error message that says slow down.
And it's customizable to some extent on a per tenant basis?
That message?
Yes.
No. That slowdown message is system-wide, and then your system can do whatever it wants with that.
But the
application has to receive that error and then act on and then display something that's appropriate.
Yeah. But we do give a warning level as you're about to hit the threshold, and so those kind of things those alerts are available.
So here's a warning level, and then the actual enforcement. Same message. These are controlled via API. So say you figure, oh, this group needs more, so you could then just send an API command or use RCMC to adjust that threshold up or down. Want to do this one?
Yeah, let's show this one.
And those rights we had before for like a group admin, etc., those are flexibly configurable because the questions being asked on the internet.
Correct. Yes.
I figured as much. That'd be painful if not.
All right, this is the quality of service demo.
Mike. You guys. Oh yeah. Mike. Good.
Is this better? Okay, first we're going to assign QoS settings to a user in the Cloudian Management Console. We're searching for a user to edit. We're going to pick Simone and click Edit, then go to User QoS. We can control the data in kilobytes per minute, data outs kilobytes per minute. Well, we're going to use no settings right now, and we're going to generate load 1 megabyte 50 times. All the requests are going through successfully, no problem. Now we're going to observe what happens when you actually change the settings. So we're going to go back to CMC, and under data bytes in kilobytes per minute, we're going to change it to 100. Then we're going to go back to our load generator application and see. Exceptions are being reported, as you can see here. It says slow down. You can't really see it too well. So now we're going to change it back and see what happens with our application. And all our puts are now successfully being put in the system. Okay. That concludes our QoS demo. Thank you.
So from that, so that's a rate limit.
Yeah.
And we also define this user or session has a minimum throughput capability. So that's maximum. Can we set minimum?
We cannot right now.
Okay.
No.
That's a great question. I mean, that's one of the things we're looking at in terms of roadmap, because that's very desired that I can give you a minimum, then I can actually charge you different kind of types in terms of service levels.
Yes, granting reservations in addition to having maximums.
Yes.
Or limits, I guess.
So I'll just very quickly touch about our S3 API. So S3 is a dominant, AWS S3 has several trillion objects. There's thousands of applications that write S3, SDKs for any possible language you could have, tools, easy to find developers, etc. So we believe S3 is won the API war, and it's a very full-functioned API.
Did you know there was an API?
We strongly defend our S3 conformance. We believe we have the strongest and the best. A lot of people claim S3 API, but they provide basic get, put, delete. That's not S3. S3 includes other advanced features like this. You could specify a version of an object that maintains the history of your old versions of the objects. You could do multi-part upload by dividing a large object into multiple chunks, uploading them in parallel. You could do server-side encryption. You could do per object encryption based on requests. You could set ACLs according to per object, per bucket policies. You could build a website based on S3. A lot of what we do and a lot of time that the engineering team spends is working on our S3 compliance. We have bug for bug compliance. We have different types of testing tools. We have our standard Python functional regression testing cases. We have a couple proprietary tools that are very valuable. Model S3 keeps a separate logical model of the data, and then we could run different S3 operations. This is very valuable for upgrades. We do upgrades in place, rolling upgrades. We have a separate tool that's a pure logical programming language that builds a model of what the inputs and outputs should be, and then randomly generates test cases based on that, thousands of test cases that are different on each run, and then checks for API correctness at the response level and as well as at the error code level. So even though you get a 400 bad requests, there's a little message in the body of that request that Amazon returns. We match that as well, and we test for that.
Yeah, one of the things we do here is we work really closely with Amazon on this. We were actually just up at Amazon again this week, and it's something that to really maintain this compliance, it's partnering with them really closely, making sure we are aware about what changes go in, we can enhance it further. They're actually really good to work with.
So this is...
They actually let you know when changes are coming?
They sometimes
okay,
do,
they let you know
don't.
when changes have happened?
honestly, the way the S3 API evolves, it actually is, it's very dynamic, right? It's evolving kind of all the time, and they're very responsive to customers, which I just love to see. So as customer feedback comes in, that's when decisions are made in terms of new APIs. So it's really about us staying engaged in that whole process as well.
Sure beats working through SNIA.
It's a lot quicker. It's a lot quicker, and it builds what customers want, which is why I think it's getting used.
Just finish up, same message. A lot of enterprise features that are required to make this enterprise ready, and all that's controlled via our APIs.